In Module 5, Lesson 3, we're going to extend our understanding of area of triangles to include acute triangles as well. So our beginning exercise asks you to work with a partner and determine if the area formula A equals 1/2 times base times height is always correct. And you may use a calculator, but be sure to record your work on your paper as well. So what we have are two right triangles, this larger one to the right and this smaller one to the left. And so the area of the two right triangles would be 1/2. We'll start with this one, times 12.6 times 12. Which is 75 6/10 square centimeters. And then the second one, the one on the left, would be 1/2 times 12 times 9. And I'm sure you'll notice that I did height times base, and it doesn't matter, remember, because multiplication is commutative. So we can multiply in any order. And that is 54 square centimeters. And so to find the total area, we would add 75 6/10 plus 54, and that will give us 129 6/10 square centimeters. Then if we use simply the area of the whole triangle, we would have 1/2 times the full base, which is 21 6/10 times the height. And that too gives us 129 6/10 square centimeters. So we found that worked fine for this triangle. We'll try it again with our next 1/2. We'll start with this triangle on the left, 1/2 times 8 times 5 2/10. And that was 20 8/10 square feet. And then the triangle on the right is 1/2 times 3 9/10 times 5 2/10. And that is 10 14/100 square feet. And when we add them together, we get 30 9/400 square feet. Taking the whole triangle, then, we would do 1/2 times the full base, which is 11 9/10, times the height, which is 5 2/10. And that as well gives us 30 9/400 square feet. Next triangle is just slightly more than a right triangle. And so if we split it apart, we have 1/2 times 2 times 2 5/6. And that is 2 5/6. Square inches. And that may seem strange to you, but remember, we're multiplying 1/2 times 2, and 1/2 times 2 equals 1, and 1 times 2 5/6 is 2 5/6. So our smaller triangle, 1/2 times 5/6 inch times 2 and 5/6. And that, when we simplify, is 1 and 13/72 square inches. And then if we add them together, we get 4 and 1/72 square inches. And our proof, 1/2 times 2 and 5/6. That's what we get when we add 2 and 5/6 inches together, times 2 and 5/6, which is our height, gives us 4 and 1/72 square inches, which is again the same. And our final drawing is turned pretty much upside down. So again, don't let that throw you off. 1/2 times our base times our height. Now for this larger triangle, we would have 34 and 32, because remember, the sides of the base and the height are the two sides that create the right angle. So we have 34 times 32. And that gives us 544 square meters. And then for our other triangle, we have 1/2 times 12 times 32, because it's the two sides that are creating the right angle. And in this triangle, of course, this would be the right angle. We get 12 and 32 making that right angle. And that equals 192 square meters. Then we need to add together the two areas, which is 736 square meters. And then calculating the area of the whole triangle, we would do 1/2 times these two bases added together, which is 46, times our height, 32. And again, that gives us 736 square meters, which should be ample proof that the formula for area of a triangle works also for acute triangles. In number 2, can we use the formula area equals 1/2 times base times height to calculate the area of triangles that are not right triangles? And yes, we absolutely can. We just need to be able to find the height of the triangle. Because again, in a right triangle, the height is one of the sides. But in any other kind of triangle, the height would have to be drawn in or given to us in some piece of information. Otherwise, we don't have the height and we can't calculate the area of a triangle without the height. In number 3, we're asked to examine the given triangle and the expression and explain what each part of the expression represents according to the triangle. 1/2 is given in a triangle formula because triangles are half of some type of parallelogram. Then the 11 is the base. Because 3 and 8 feet are added together. And 4 is the height because it is perpendicular to the base. Okay, number 4. Joe found the area of a triangle by writing 1/2 times 11 times 4, while Caitlin found the area by writing 1/2 times 3 inches times 4 inches plus 1/2 times 8 inches times 4 inches. Okay, if we look at this triangle again, we see Joe found the area by multiplying 1/2 times 11 times 4, which is the total dimensions of the base times the height. And Caitlin did 1/2 times 3 times 4 and 1/2 times 8 times 4. So Joe found the area of the complete triangle in one formula, while Caitlin found the areas of the smaller triangles and added them together. Number 5. The triangle below has an area of 4 and 7/600 square inches. If the base is 3 and 4/10 inches, let h be the height in inches. And so in part A, they ask us to explain how the equation 4 and 7/600 square inches equals 1/2 times 3 and 4/10 inches times h represents the situation. And we could start by showing the formula. Area equals 1/2 times the base times the height. And I'm going to put the base and height in parentheses. And then we will say 4 and 7/600 is the area. The base, let's see, 3 and 4/10 is the base, and the height is the part we are looking for. The numbers were substituted. And when we solve the equation, first of all, we would need to multiply 3 and 4/10 times 1/2, which would give us 1 and 7/10 times h. And then we would divide by 1 and 7/10 on each side. Which will give us 2 and 8/10, and these are our units. Our units are in inches. And then you will practice on your own to ensure that you understand and can use the concept in a variety of different ways.